After the session, you'll be able to know the use and steps to use the winding strips, plane the cross grain, plane the edge, test the accuracy of flatness, test the accuracy of squareness, test the accuracy of the inside squareness, test the accuracy of twistness on surface. Let's first go through the job sequence and then the skill sequence. Let's start. Use of winding strips. Winding strip is a pair of perfectly straight pieces of timber with parallel edges. Usually they are about 375 mm long and 35 mm wide and 20 mm thick. They are used to test the flatness of any wooden surface. For testing the job for flatness, one stick is placed across one end and the other stick is placed across the other end of the job. The top edges of the sticks are sighted, and if they are not parallel, the surface is said to be uneven or they are said to be in winding. Again, if the high levels of the job are planed, the winding strips are placed on the job and tops of the strips coincide, then the level is said to be out of winding and is perfectly flat. To check the surface for wrinkles or unevenness, breadthwise or lengthwise winding stripes are used. Necessity for checking flatness and twisted. The planed wood must be free from twist and up and down. The furniture legs will sit properly on the floor. Before selecting the wood, inspect the wood without twist and it should be flat. To find the up and down in the wood, winding strip are used. Good wood without twist and up and down used for preparing good joints. If the wood is good, the door and window can be closed properly without clearance. Task 2. Cross planing. Keep the blade sharp to plane across the grain. Set the jack play for planing. Place the job on the workbench or hold the job on the carpenter's vise with face side up. Hold the job 200 into 25 into 250 mm in the vise. Tight the job 15 mm above the vise, keeping the packing piece sidewards. Trim off the corners with firmer chisel to avoid splintering. First, plane across the grain in one edge, then plane from the other edge. Plane diagonally from one edge corner to the other. Plane towards the middle from the edges. Check flatness with tri-square and straight edge. Plane again. If high spots are found, repeat the procedure till you get a leveled surface with a measurement of 200 into 20 into 250 mm. Task 3. Edge planing. Check the measurements of the job. Start planing from one end. Trim off the corner with firmer chisel to avoid splintering. Hold the job in the vise. Before starting to plane, clamp a waste piece of wood behind the corner to avoid splintering of the job. Continue the planing till you get a leveled surface. Start planing from the other end. Continue the planing from both ends towards middle till you get a leveled surface. Remove the waste wood attached to the end. Check the leveled surface of the end with a tri-square. Repeat the same procedure for the other end. Job sequence. Test the accuracy of the flatness. Place the job on the workbench. Hold the tri-square in right hand. Test the flatness of the surface. Test the accuracy of the squareness. Place the job on the workbench. Hold the tri-square in right hand. Test the squareness of the job. Test the accuracy of the inside squareness. Place the job on the workbench. Hold the tri-square in right hand. Test the inside squareness of the job. Test the accuracy of the twistness on the surface. Place the job on the workbench. Hold the tri-square in right hand. Test the twistness of the surface. Recap. Winding strips 375 mm long, 35 mm wide and 20 mm thick. Test wooden surface flatness. Placed at opposite ends, if top edges aren't parallel, it's in winding. When planing levels, if winding strip tops coincide, it's out of winding, indicating a flat surface. Ensuring wood is twist-free is crucial for furniture legs to sit well. Cross-planing involves sharp blades, jack planes and trimming with a chisel for a level surface. Edge planing checks measurements, uses a waste piece to avoid splintering and repeats the process for both ends. This training focuses on testing flatness, squareness, inside squareness and surface twistedness. Trainees learn to use a tri-square to assess these parameters on a workbench, enhancing woodworking accuracy skills. Hope you understood everything taught in this session. See you in another video. Thank you and goodbye until then. Hello trainees. Today we are going to learn to grind and sharpen the plane blade. The objectives of this video are: after the session you will be able to grind the plane blade, sharpen the plane blade. Let's start. Job sequence. Select the jack plane. Remove cutting iron, cap iron and the wedge from the jack plane by slightly striking by hammer. Select the grinding wheel. Check the grinding wheel for cracks. Ensure that there is enough coolant in the container. Lower the protecting shield near the tool rest. Adjust the tool rest 2 mm closer to the wheel if necessary. Switch on the grinder machine. Holding the cutting bevel across of the cutting iron must be at an angle of 20 degrees to 25 degrees. Rest the body of the cutting iron on the tool rest. Allow the point to touch the wheel. Keep the pressure as minimum as possible to prevent excessive heating of the cutting bevel. Dip the cutting iron in a coolant frequently. Avoid blue color from cutting edge, icy annealing effect. Finish the grinding of cutting iron with oil stone. Place the blade until the cutting edge is parallel on the stone. Move the blade backward and forward on width of the stone until a burr is formed on the flat side of the blade. Turn the blade over and hold it perfectly flat on the stone. Rub from side to side until burr has disappeared to get fine cutting edge. Reset the cap iron, cutting iron and the wedge of jack plane. Set the cap iron and cutting iron keeping a gap of 1 mm. Sharpening of a plane blade is necessary to produce a keen cutting edge for good surface finish and perfect planing with minimum effort. Sharpening and honing. The process of sharpening is carried out on oil stone by rubbing the blade with its bevel down, maintaining a constant and correct angle 25 degrees to 30 degrees. This rubbing is continued until a burr or wire edge is produced. The burr is removed by rubbing the back of the flat face of the plane blade on the oil stone, keeping its bevel up. During sharpening, oil is used to minimize the heat caused due to friction and to float off the metal particles from the pores of the oil stone so as to prevent clogging of the oil stone. Hope you understood everything taught in this session. See you in another video. Thank you and goodbye. Until then. Hello trainees. Today we are going to learn to use the bench vise, bench hook, bench stop and also their application. The objectives of this video are: after the session you'll be able to uses of bench vise, bench hook and bench stop. Application of bench vise, bench hook and bench stop. Let's start. This device is called a carpenter's vise. It is used to hold the wooden pieces securely when the different operations like sawing, drilling or filing are performed on them. Now let's see how it is used in each scenario. First, we have to separate the closed jaws of the carpenter's vise by turning the handle. If the handle does not move, try turning in the opposite direction. This should cause the jaws to open up. Now place the workpiece which is to be sawed in between the two jaws. Ensure that the part of the workpiece to be sawed off is lying outside the jaws. After the workpiece is placed in the correct position, rotate the same handle in the opposite direction. This will cause the jaws to clamp the workpiece. Do this a little further until the workpiece is tightly clamped between the two jaws. Now use the saw to cut off the marked parts of the workpiece. Do this a little further until the workpiece is tightly clamped between the two jaws. Now use the drill to drill the marked parts of the workpiece. After the workpiece is placed in the correct position, rotate the same handle in the opposite direction. This will cause the jaws to clamp the workpiece. Do this a little further until the workpiece is tightly clamped between the two jaws. Now use the file to file the edges of the workpiece. We are done with this device. Let's move on to the next device. This device is called a bench hook. It is used to hold the wooden pieces securely when cross-cutting is performed on a wood piece using a handsaw. Let's look at its parts first. It has two parts as shown, a hook and a stop. Now let's see how it is used. First, the bench hook is placed such that its hook is against the edge of the table. Then the workpiece to be sawed is placed such that the part to be sawed off is in line with the stop's edge. Make sure that you hold the top of the part of the wooden piece that is against the stop. Then slowly place the saw over the line drawn on the wooden piece and start moving the saw back and forth along this line to cut the wooden piece. One helpful tip is that you can mark standard lengths that you always use on the top of the stop to make it easy for you to cut small pieces of wood without always using the measuring devices. We are done with this device. Let's move on to the next device. This device is called a bench stop. It is used to hold the wooden pieces securely when performing different operations on it, like planing, grooving, rebating. Now let's see how it is used. Usually bench stops are placed inside the work table. To use it, we need to turn it in a direction which will cause one end of it to rise above the table surface. The wooden workpiece is placed such that it is against the bench stop's raised part. This will ensure that when any activity like planing, grooving, rebating is performed on the wooden workpiece, it does not move in any direction that's parallel to the bench surface. When many such bench stops are used to hold all the edges of the workpiece, it will not move in any direction. This will make the workpiece even more stable. We are done with this device. Recap. A bench vise is used to hold wooden pieces securely even when operations like sawing, chiseling are performed on the saw. Similarly, a bench hook is also used to hold the wooden pieces securely. A bench stop is used to stop the wooden piece. Hope you understood everything taught in this session. See you in another video. Thank you and goodbye until then. Hello trainees. Today we are going to learn about the different types of saws and how to do rib cutting. The objectives of this video are: after the session you will be able to the different types of saws and how to perform rib cutting. Let's start. Task 1. There are many types of saws for cutting wood pieces. Some of the saws are made specifically to make straight cuts and other saws are designed specifically to do curved cuts. And some of the saws like cross-cut saw are designed specifically to cut perpendicular or at an angle to the wood grain. Types of saw. There are mainly two major types of saws, being straight cutting saws, curve cutting saws or special saws. You can see the saws that we are going to be looking at. First, we will look at rib saw and straight cutting saws. The name of this saw is rib saw. The blade of the rib saw is made out of thin spring steel. Rib saw is used for sawing along the grain. The blade of the rib saw is fixed to the wooden handle by screwing. Teeth of rib saw vary in size as per the need of the fitness of work to be done. The handle of the rib saw is made out of beech or apple wood. The rib saw has 2 teeth per centimeter length. The length of the rib saw is 60 to 70 centimeters. The rib saw is specified by its length. The teeth angle of rib saw is less than 90 degrees. The rib saw has 3 to 6 teeth per 25 millimeter. Next we will look at cross-cut saw. Cross-cut saw is used for cutting across the grains of timber. Length of the blade is 56 to 70 centimeters. It has 5 to 9 teeth per 25 millimeters. Cutting angle of teeth 90 degrees. Teeth has different shape to that of rip saw. Finer pitch blade is preferred for hardwood. Blade with coarse pitch is used for softwood. Let us now look at hand saw. The length of the hand saw is less than the length of the rip saw. Hand saw is generally used for lighter work. Let us now look at panel saw. It is the most commonly used saw for woodworking. Panel saw is available in many sizes. It has 10 to 12 teeth per 25 mm. The length of this saw is 50 centimeters. This saw is specifically used for cutting panels and for doors. Let us look at tenon saw. It is rectangular in shape. Length is 25 to 40 centimeters long. It is used for finer works like tenon. Main use is making short and straight cuts. Let us look at the next saw, which is dovetail saw. The appearance of the dovetail saw is very similar to the appearance of the tenon saw. Its blade of dovetail saw is thinner and narrower as compared to the tenon saw. It is used for finer work, specifically used for cutting tongues for dovetail joints. It has open handles. Length of blades is 20 to 30 centimeters. It has open handle. Now we will move on to the special type of saws which can cut curves. We will first look at bow saw. The bow saw consists of a frame made out of wood, carrying connecting bar, a string, lever, and two handles on both sides. This type of saw is used to cut external curves of the job. Length of blades 20 to 30 centimeters and carries 6 points per centimeter. Coping saw has very fine blade held in stiff wire frame. Used for cutting sharp and quick curves internal and externally. Length of blade in coping saw is 25 centimeters. The next saw we are going to see is fret saw. The fret saw has a very fine blade of 150 mm to 180 mm long, which helps in a steel frame of 300 mm to 500 mm. This type of saw is specially used to cut thin wood pieces. The next saw which we are going to be looking at is compass saw. This saw has a narrow tapering blade 300 mm to 450 mm fitted in a handle. It is used for cutting large interior curves. It is necessary to bore a hole in to start the saw. 8 to 12 teeth per 2.5 centimeters length. This saw is called nest of saw. It consists of 3 blades with detachable handles. To use a different blade, just detach the existing blade and attach the blade you want to use. The blades are pruning blade, compass blade, and keyway hole blade, which are used cutting curve. Length of blades are from 25 to 40 centimeters. Keyhole saw. The length of this saw is 20 to 30 centimeters long blade. It is 6 mm wide near the handle and 3 mm wide at the toe. This saw is comparatively a small saw, so this type of saw is mainly used for intricate and internal works. The length of the blade is 25 to 35 centimeters. Task 2. Ripping. Let us start by marking the wooden piece. Check the wooden piece size with a folding rule and make sure that the length, breadth and height measures 450 mm into 25 mm into 200 mm. We need to mark the job as per drawing using tri-square and marking gauge. Let's see how to mark the job. Place the job horizontally on the workbench. Mark 50 mm from the left of the job using a woodwork specialist's pencil, folding rule and straight edge. Mark every interval of 50 mm to length of 400 mm. Repeat the procedure on the end side and back side, keeping the tri-squares on the edge of the end side. Mark the line with a straight edge. Now let's see how to hold the job firmly in the woodwork specialist's vise vertically, leaving 150 mm above the vise and parallel to the jaws. Make sure that the woodwork specialist's vise is clean. If not, then use a cleaning wire brush to clean the woodwork specialist's vise and make it free from sawdust. Now open the jaw of the woodwork specialist's vise. To open the jaw, turn the handle in the anti-clockwise direction. Open the jaws wide enough to hold the wooden piece vertically. Hold the job vertically 150 mm above the vise and parallel to the jaws. Close and tighten the jaws to hold the job firmly in the vise. The position of your feet should be 90 and 70 degrees as shown here. Make sure that you don't over-tighten the wooden piece in the bench vise and keep a waste wooden piece on both sides of the jaws so that the pressure is distributed evenly and so the vise does not damage the wooden piece. Set and mark the saw. Grip the saw handle with the right hand index finger along the side as shown. Precaution: make sure that the wooden piece is clean on all sides. If not, then use the sandstone to clean the wooden piece. Place the saw on the marked line at 65 degrees. Hold the handle to form an angle of 65 degrees with the wooden piece. Move the saw forward and backward with even pressure to form a saw cut using the left hand thumb as a guide. Use the full length of the saw to cut so that the saw does not become blunt on one region. Once you sawed the 150 mm region, saw until you reach the 400 mm mark that we have marked. Do the same for the other marked lines. We have completed the sawing, so let's finish the rib sawing. Make sure that you don't go off course by repeatedly checking the deviation of the blade from the mark. Recap. In the first task, we looked at wood saws, categorizing them into straight and curve cutting types. Specific saws like rip, crosscut, hand, panel, tenon, dovetail are detailed, including blade material, length, teeth, and uses. Hope you understood everything taught in this session. See you in another video. Thank you and goodbye until then. Hello trainees. Today we are going to learn to use and practice of portable power circular saw. The objectives of this video are: after the session you will be able to set the circular saw for sawing. Perform the sawing operation with portable power circular saw. First, we will go through the job sequence and then the skill sequence. Let's start. First, we need to take the following precautions. Ensure the plug and the lead of the portable power circular saw are not damaged. Make sure the on-off switch works properly. Try to avoid cutting small pieces. Don't wear long hair. You should also use a dust mask. Move the circular saw against the straight edge. When sawing, use the portable power circular saw. Move it only in the forward direction. Let's move on to the job sequence. Check the size of the wooden piece using folding rule. Mark as per the drawing using marking gauge and tri-square. Draw 3 parallel lines on the job of distance of 75 mm apart. Width size using folding rule, carpenter pencil and marking gauge as shown. Place the job on workbench. Set the blade on portable power circular saw on the part of arbor. Set the cutting guide on depth of job thickness. Support the straight edge and parallel line in job. Stock must be held flat on the table against the cutting guide. Switch on the machine. Start sawing slowly with even pressure. Saw the stock angle along the marked pencil line. Repeat the same procedure for all other marked line. Let's move on to the skill sequence. Select the right blade for the application. This is very important. Also, select the proper size and shape arbor hole. Place the blade on the arbor and tighten the nut with a spanner. Move the table, support the cutting, tighten the guide. Lock them in position on cutting guide. Check all the adjustments. Always wear safety goggles. Use sharp blades. Does it have the proper size and shape arbor hole? Set the workpiece. Objective: this shall help you to perform operation. Note: round log should not be cut. Sawing operation. Hold the job against the cutting guide. Test the saw cut by feeding a rough piece. Saw on marked line by machine pushing the job. Continue the process with even pressure and complete the sawing operation. If you hear a clicking noise, switch off the machine. That's it. We are done with the sawing operation. Recap. Ensure safety by checking the portable power circular saws plug, lead and switch. In the job sequence, measure wood, mark parallel lines, set the blade depth and cut following the marked lines. In the skill sequence, choose the right blade, secure it on the arbor, adjust guides, wear goggles and test with a rough piece. Perform the sawing operation with even pressure and if clicking occurs, turn off the machine. Always prioritize safety during the process. Hope you understood everything taught in this session. See you in another video. Thank you and goodbye until then. Hello trainees. Today we are going to learn about sharpening and setting of saw blade. The objectives of this video are: after the session you will be able to sharpening and setting of saw blade. Let's start. Job sequence. Let's first see all the steps that we need to follow to sharpen and set a saw blade. These steps are topping, reshaping, saw setting, setting, notched saw setting, piler saw set, sharpening. Let's start with the topics one by one. Topping. Fix the saw in the saw vise if required by keeping a waste wooden piece on both the sides of jaws. Set the flat in the grooved wooden block to level all the teeth by running a fine flat file along the length of the saw teeth. The file must be kept flat and passed lightly over the tops of the teeth and leveled. We are done with this topic. Now let's move on to the next topic. Reshaping. File all the teeth to their correct shape and size with slim tapered triangular saw file. Press firmly against each gullet and held at right angles across the blade. Make all the teeth the same shape, the front edge being 70 degrees to 80 degrees to the line of the teeth. Maintain the same grip throughout filing. File each gullet until teeth of the finished side hits a point and half the flat on the next teeth is filed away. At the end of the reshaping process, the teeth should all be in one and the same level and shape. We are done with this topic. Now let's move on to the next topic. Saw setting. When a saw is being set, the blade should be fastened into the saw clamp. When one row of the teeth has been set, the saw is reversed in the clamp and then the other row is bent. We are done with this topic. Now let's move on to the next topic. Setting. The notched saw setting. Notched setting operation consists of bending over the teeth alternately to one side and then to the other. The notched saw set demands more practice than the pilers. We are done with this topic. Now let's move on to the next topic. Piler saw set. The pilers can be adjusted to the size of the teeth. Bend every teeth about 2/3 of its length and do the same degree sideway. Total thickness of saw set should be 1-2 times the saw thickness. Thickness of the blade. Total width of the set blade. We are done with this topic. Now let's move on to the next topic. Sharpening. Select a tapered triangular saw file with slightly round corner. Start sharpening at the point of the saw. Sharp the tooth of the saw at 30 degrees to 45 degrees. Hold the file at 90 degrees both vertically and horizontally while filing the tooth of the saw. Remove the burr produced by the file by passing an oil stone lightly along the side of the teeth. Check the saw teeth. We are done with this topic. Recap. To sharpen and set a saw blade, follow these steps. Begin with topping, securing the saw in a vise and leveling teeth with a flat file. Proceed to reusing a triangular saw file to maintain uniform shape and size, filling each gullet until teeth are level. Hope you understood everything taught in this session. See you in another video. Thank you and goodbye until then. Hello trainees. Today we are going to learn to use the country drill, hand drill, ratchet brace, breast drill, hand auger and drill bits. The objectives of this video are: after the session you will be able to identify the use of country drill, hand drill, ratchet brace, breast drill, hand auger and drill bits. Let's start. This is a hand drilling machine. The bevel gear type drilling machine is used for drilling small diameter holes up to 6 mm. Let's move on to the next tool. Breast drilling machine. The breast drilling machine is used for drilling holes of larger diameter as more pressure can be exerted. Drills between 6 mm to 12 mm can be used on these machines. Let's move on to the next tool. Country drill. This is made out of wood. Its length ranges from 100 mm to 250 mm wooden stick having length of 60 cm and 90 cm length of thread are necessary to rotate this drill. The thread is ringed around the wooden stick like a spring and used for rotation. Drill bits having range of diameters from 3 mm to 12 mm are fit into drills for drilling. Let's move on to the next tool. The ratchet brace. The ratchet brace is provided with a ratchet mechanism. The ratchet permits the brace to be rotated to and fro while the chuck rotates in only one direction. The cam ring can be set in positions for clockwise and anti-clockwise rotation. The brace drill has a tapered tank for use in chuck of the brace. The drill has a single cutting edge. Because of this, the drill must not be used where accuracy is required. Let's move on to the next tool. Twist bit. It is also called an auger bit. This bit has both a twisted point and a twisted shank. The twisted point draws the bit into the wood. Two varieties are made just for one hardwood without spurs or scriber. Second one for softwood with a spur. This is particularly useful for boring deep holes in hardwood or softwood. It is useful when boring in end grain. The long twisted shank will keep the hole straight and throw out the waste. Size 6 mm to 45 mm. Let's move on to the next tool. Center bit. This bit differs from other bits as regards to shape. Its cutting action is similar to the twist bit. The center point guides the bit. The cutting points are sometimes threaded. Spur or scriber, slightly shorter than the point, cuts the rim of the hole. Router or cutter, slightly shorter than the point, cut the waste portions. These bits are suitable for boring shallow holes or holes through thin timber only. There is no guiding shank to keep the boring straight. Size 6 mm to 50 mm up to 25 mm is equal to 16 numbers. 25 mm to 50 mm is equal to 8 numbers. Let's move on to the next tool. Expansion bit. This bit is able to adjust to cut holes from 12 mm to 75 mm. Its cutting action is similar to the center bit for boring shallow holes through thin wood. Let's move on to the next tool. Cobra bit has a twisted point which draws the bit into the wood. Care must be taken not to split the timber while boring, especially when near the end. It is used for boring small holes for nails and screws. Size 2 mm to 10 mm. Let's move on to the next tool. Dowel bit. Dowel rounder or sharpener, similar to the twist bit. It is shorter than the twist bit for boring holes for dowels and preliminary boring out of waste of mortises. Size 6 mm to 15 mm. Let's move on to the next tool. Countersink bit. These bits have tapered cutting point which enlarge the tops of holes. This process is called countersinking. For countersinking the tops of holes to receive the head of countersunk head screws. The snail pattern is most suitable for hardwoods. Size 6 mm to 20 mm. Let's move on to the next tool. Forstner bit. This bit differs from other bits, is guided not by a center point but by its circular rim. It can be used to bore at any angle to the surface of the work regardless of the direction of the grain. For boring skewed holes, called pocketing for screws, rails of the table. Flat-bottomed holes in pattern making and recessed carving designs. Size from 6 mm to 40 mm. Let's move on to the next tool. Gimlet. Has a twisted point which draws the bit into the wood. Has a small cross handle for hand boring. For boring small holes for screws and nails where the brace cannot be used. The gimlet must be used with care. It will split the timber. Let's move on to the next tool. Broadawl. Consists of a thin steel rod which is flattened to a small cutting edge at one end. The tang fitted into a box wood handle at the other end. The flat cutting edge is placed across the grain and forced into the timber while being twisted back and forth, so that the fibers are cut, making a small hole. For making small holes where the brace and bit is not necessary. Size 3 mm to 12 mm. Recap. We saw the use of country drill, hand drill, ratchet brace, breast drill and hand auger and different drill bits. Different drill bits are used depending on the different purposes. Hope you understood everything taught in this session. See you in another video. Thank you and goodbye until then. Hello trainees. Today we are going to learn about demonstrating the portable power planer machine and its functions. The objectives of this video are: after this session you will be able to Introduction to portable power planer, using the portable power planer machine job sequence, grinding and sharpening of blade and planer blade setting skill sequence. Let's start. Introduction to portable power planer and its working. The portable power planers are used to make sure that the surfaces are made to be smooth planed on the face side, face edge and face end. It is important that the planer should always be planing in the same direction as the grain of the wood, that is, along the direction of the grain. The proper feed rate will depend on the type of material being cut and depth of the cut. Power planes are available in sizes 50 to 125 mm. The proper feed rate will depend on the type of the material being cut and depth of the cut. Power planes are available in sizes 50 to 125 millimeters. Maximum width of cut the plane will make at one pass over the wood, that is, the width of the sole which equals the length of the cutting blades. Generally, two cutting blades are bolted to a cutter block which is revolved at high speed, 12,000 to 15,000 revolutions per minute, by gears or belts connected to an electric motor mounted on the body or the plane. Depth of cut up to 6 millimeters is regulated by a star wheel or knob which sides the front portion, front shoe, of the sole on an inclined plane. Most planes are fitted with a fence to guide the plane when squaring, beveling or mitring edges and ends. Bevel gauge can be fixed to either side 135 degrees to the sole. The front shoe has a rebating groove machined along the edge for 9 mm wide by 9 mm deep. Wider rebates may be produced by making 2 or more passes of the plane. Job sequence. We are going to remove and sharpen the planer blade using oil stone. Using the Allen key, we are going to set the planer blade in the cutter head. Set up the in-feed and out-feed table. Hold the job using the bench vise. Use your right hand to hold the plane and keep the index finger on the trigger switch. Hold the front handle of the plane using your left hand. Press the trigger switch on the machine. Place the machine straight on the job and give forward stroke. The machine should always be in a horizontal position. Feed the job against the cutter head for planing to the required size. Use the trigger switch to turn off the machine. Using the tri-square and the steel ruler, check the flatness and thickness of the planned wooden piece to ensure that it is of the correct dimension. We are done with the job. One important note: keep the machine on its side when not in use. Skill sequence. There are two parts to the skill sequence. 1. Grinding and sharpening of plane blade, and 2. Planer blade setting. Now let's focus on part 1. Grinding and sharpening of plane blade. Grinding. The jaws of the grinding machine are open to insert the cutter. In between the jaws of the grinding machine, the cutter is inserted. Set the cutter evenly projecting from the jaws of the grinding machine. Make sure that the cutter is extended to a distance of 10 mm to 14 mm from the jaws of the grinding machine. Set the angle of jaws to 30 degrees for grinding the cutter. The cutter has to be adjusted against the grinding wheel for it to be grinded. Turn on the machine. Move the cutter to and fro against the grinding wheel uniformly by hand. Continue the grinding till the required angle of cutter is obtained. Sharpening. The oil stone along with its block can be placed on the workbench top. Use the recommended lubrication oil while sharpening. Move the cutter backward and forward on full length with the oil stone until a burr is formed on the flat side of the cutter. The burr can be felt by rubbing lightly with a fingertip. Turn the blade over and hold it perfectly flat on the stone. Rub from side to side until burr has disappeared. Till you get fine cutting edge, continue the sharpening procedure. Planer blade setting. Setting the planer blades cutters in the slot of the cutter head, place the blade. Set the blade such that it is 3 mm outside the cutter head and parallel to the cutter head using the cutter lock. The cutter's projection needs to be checked. Tight the blade on the cutter head with bolt using Allen spanner. Test the projection of the blade edges by rotating the cutter head. Generally, two cutting blades are bolted to a cutting block. Precautions for planer blade setting. Check electrical and mechanical parts. Keep the lead behind the plane. Do not force the plane to cut rapidly. Let's quickly recap. We learnt about portable power planer machines and their functions. The video covers the introduction and operation of portable power planers, emphasizing the importance of planning in the direction of wood grain. The job sequence involves removing, sharpening and setting planer blades using in-feed and out-feed tables and ensuring correct dimensions. The skill sequence details the grinding and sharpening of the blade along with precautions for planer blade setting. Key points include maintaining a horizontal position during operation and proper storage. Participants will gain proficiency in using portable power planers for woodworking tasks. Hope you understood everything taught in this session. See you in another video. Thank you and goodbye until. Hello trainees. Today we are going to learn about demonstrating the use of different types of chiseling along and across the grain. The objectives of this video are: after the session you'll be able to chisel and different types of chisels, chisel across the grain, mark the piece as per the drawing, chisel across the grain and along the grain. Let's start. Chisel are used for shaping and finishing the parts of wood joints. They are also used for shaping different profiles in woodwork. The size of the chisel is determined by width of the blade and type. All chisels consist of four main parts: the handle, the blade, tang, ferrule. The blade of a chisel is made of forged tool set. Grinding angle 20 to 25 degrees. Sharpening angle 30 to 35 degrees. Types of chisels: bench firmer chisel, bevel-edged firmer chisel, registered firmer chisel, paring chisel, socket firmer or socket mortise chisel, mortise chisel, gauge chisel. Bench firmer chisel. This is used for general chiseling purposes. Strongly made, it can be used for light chiseling with a mallet. The blade is rectangular in the cross section. The handle is made of beech or ash wood. It has a brass ferrule. Tang is fixed inside the ferrule. It is available from 3 mm to 50 mm. Bevel-edged firmer chisel. It is more convenient for lighter works and paring works and in places where ordinary firmer chisel cannot be used, such as cleaning up corners and joints. Bevel-edged firmer chisel has two edges beveled along its length, which makes it lighter and the edges thinner. Size varies from 3 mm to 50 mm. Registered firmer chisel. It is used for heavy work such as mortising. The use of mallet is necessary here. It is stronger than ordinary firmer chisel. It has a thicker blade and iron ferrule at both sides of handle. A leather washer is provided between the shoulder of the blade and the handle to act as shock absorber when the chisel is hit by the mallet. Paring chisel. It is most suitable for all paring work such as finishing off joints. It has an extra long thin blade with beveled edges. It should never be used with a mallet. The handle is made of beech and octagonal in section. Size varies from 3 mm to 50 mm. Socket firmer or socket mortise chisel. It is used for extra heavy work. The blade is thicker and stronger than other chisels. It is able to withstand the blows of the mallet and level out the cover of mortises. The ash handle provided with ferrule is fitted in the socket in the blade. Size varies from 3 mm to 50 mm. Gauge chisel. Chisels are blades of circular section called as gauges or hollow chisels. According to the position of the cutting bevel on the blade, there are two main types inside beveled gauge: outside beveled firmer gauge and scribing gauge. Mortise chisel. The mortise chisel is designed to withstand hard, rough wear, and the thickness of the blade permits the leverage necessary to clear the mortise and keep the blade true. It has strong handle and the blade is fitted into it by a tang as with the socket and tang chisel. 54 common sizes of mortise chisels are 3, 4, 5, 6, 8, 10, 12, 14, 16, 20 mm in width. The chisel blade is ground slightly taper from the face towards the back and from the cutting edge towards the handle to avoid friction. Mortise chisels are used mainly for chopping mortises and are driven with heavy blows of the mallet. The sash mortise chisels have a tough leather washer between the shoulder of the tang and the handle to help absorb the shock of repeated blows. Precautions to take before using the chisel. Never hold your hand or finger before the cutting edge. Never use a chisel without a proper handle. Chiseling across the grain. Grind and sharpen the firmer chisel. Plane the job to the required size of 50 x 22 x 150 mm. Hold the job on the vise and check it with tri-square for its flatness. With tri-square, mark out lines at a distance 50 mm and 100 from left side. With marking knife and tri-square, mark out lines at a distance of 50 mm and 100 from left side. Hold the tenon saw on the line marked and saw it to a 50 mm and 100 mm from left side. Repeat the procedure for the other side. Saw it to a depth of 11 mm. Hold the firmer chisel in your right hand on the handle and guide the blade with left hand. Control the movement of the chisel with thumb and forefinger. Push it on the space to be cut. Start a chiseling away from you at the bevel of the chisel turned upwards. Start a chiseling away from you, the bevel of the chisel turned upwards. Chisel in an inclined direction up to the middle of the portion. Reverse the workpiece so that the backside comes to front and hold in the vise. Chisel the waste material away from you up to the middle portion. Repeat the chiseling. Start chiseling slowly to make flat portion. Repeat the procedure for the other side. Saw it to a depth of 10 mm. Smooth the bottom and side walls with firmer chisels. Finish the job. Chiseling across the grain and along the grain. Check the raw material for its size. Plane the job to the required size of 50 x 22 x 290 mm. Mark the measurement on the job as per the drawing. Hold the job in the vise. Cut the shoulder line down to the center line, depth 11 mm with tenon saw. Keep the tenon saw at 90 degrees to ensure cutting at right angles. Cut on the waist side of the shoulder line. With the tenon saw, make several saw cuts in between the shoulder lines almost to the center line. Place the job flat on the workbench. With the help of firmer chisel and mallet, remove the surplus material on both sides, preventing splitting of wood. Chisel out excess wood little by little starting from the top and bottom. Smooth the bottom trench portion with firmer chisel. Repeat it for the other trenches also. Marking for chiseling. Observe the provided drawing. Hold the job 160 x 60 x 25 on the bench or vise. Plane it to size 160 x 50 x 22. With tri-square and steel rule, mark 5 mm, 55 mm, 105 mm and 155 mm from one end of the job. Hold the stock of the tri-square closely in contact with the face edge and mark lines with marking knife and wooden rule at the distance of 5 mm, 55 mm, 105 mm and 155 mm on all four sides. Set the marking gauge to 11 mm and scribe on the middle of face edge and its opposite side. Let's quickly recap. In this training session, Participants will learn about using different types of chisels for woodwork, covering chiseling along and across the grain. The objectives include understanding various chisel types, chiseling techniques, and marking methods. Types of chisels discussed include bench firmer, bevel edge firmer, registered firmer, paring, socket firmer, and mortise chisels. Precautions for chisel use are highlighted. The tutorial demonstrates chiseling across the grain, providing step-by-step instructions and extends to chiseling along the grain. It concludes with marking procedures for chiseling. Participants will gain proficiency in using chisels for shaping, finishing, and creating wood joints. Hope you understood everything taught in this session. See you in another video. Thank you and goodbye until then.
Today, I will discuss the inspection and testing of concrete structures. Then, first of all, we will discuss the why inspection of concrete structures is required. Inspection of concrete structure requires to identify the defects and serviceability. The outcome of inspection can be used to specify